Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hi class, welcome back to SIC2003 Physical Chemistry Lab. Today we are going to discuss on experiment 2, which is heat of neutralization. Now this is not something unfamiliar. You know what neutralization is, so the heat of neutralization involves when one equivalent of an acid and one equivalent of base undergoes neutralization reaction to form water and salt. So today the objective is to measure the molar heat of neutralization of hydrochloric acid, nitric acid, acetic acid, and monochloroacetic acid. The base that we are going to use is a strong base, which is sodium hydroxide. Now this is an exothermic reaction, and in this reaction what you get is the combination of heat of neutralization and also heat of dilution from the dilution of NaOH. So because we are interested in this molar heat of neutralization, so you just have to tweak the equation. Okay, now to achieve this you need to use a calorimeter to actually measure the heat of neutralization. And a calorimeter is any well-insulated apparatus that can hold the reactants and products so that the amount of heat that is absorbed or released by reaction can be measured. Now ideally the calorimeter is well insulated, but the Dewar flask that is used is not a perfect insulator, so you expect that the values that you're going to obtain are not accurate. But here's the point. The point is that you know that in order to measure calorimeter you need to use the principle of using the calorimeter and what is the function. So that is the gist of this experiment, really. Okay, and the principle of a calorimeter is to use the rise in temperature to determine the energy released as heat, as your delta H, by the process that occurs in it. Now before you can actually use that to measure delta H, you actually need to calibrate the calorimeter by comparing the observed change in temperature with a change in temperature brought about by the transfer of a known quantity of energy as heat. Now what does that mean? In essence, to calibrate the calorimeter is really to determine the heat capacity of the calorimeter. Okay, in year 1 you also did something similar, in which you didn't measure, but you observed the heat of polymerization, and you use a Dewar flask as well, but a much cheaper thermometer. Okay, and so in the process you also needed to calibrate the Dewar flask, and how you did that was via heat of neutralization. Once you have determined the heat capacity of the Dewar flask, then you can move on to doing the polymerization process. So you didn't measure the heat of polymerization, but you did some observation. So now that you're in the second year, so there is an elevated process, so you need to do the calculation. Okay, so now in this case the calibration is done electrically by passing a known current for a measured time through a heater and record the increase in temperature, and only then you can actually determine the heat capacity. So you have a piece of wire which is heated electrically, and you put it inside. So you have your water inside, and you actually put in the piece of wire. So once it's heated, so you see the temperature rise until it becomes constant. Now to measure the heat capacity, this is the equation that is given in the lab manual, and so it it is equivalent to the voltage of the resistance the potential, the time, and also over the the resistance, and also the temperature change. So the current used is 0.5 amp, and the resistance is 1 ohm. Okay, so V is equals to IR, that gives VR being constant at 0.5 volt. So all you need to do in the process of finding the calibration, of finding CP, is the value of the average of the VP used, and the time, and also what is the temperature change. Then you can find CP. Once you have the value of CP, then you can use this equation, which you have also seen before in year 1, in which heat is equals to the change in enthalpy at constant pressure is equals to Cp times the change in the temperature change. So once you have done the calibration, so you will actually do the rest. Now, of course, you need to find the heat of neutralization, but before you do that, because this process will involve the neutralization and dilution of the sodium hydroxide, it's wise to actually start with the dilution, so that you start with water and NaOH, so that you don't contaminate the Dewar flask. Okay, you're going to use the same Dewar flask that you calibrate for all the other processes, for this neutralization and dilution process. Okay, start with dilution first, and then so once that is measured, so you can actually proceed with the heat of neutralization of all the 4 acids. So if you read the instructions in your lab manual, it's quite straightforward. Okay, so this is a given. It's not the most accurate, but it's just a given values that you're going to use in this for this lab report. Okay, so given that the heat capacity measured is 0.38 kilojoules per Kelvin, and given also the heat of dilution being -4 plus minus 0.4 kilojoules per mole, and given that the rise in temperature are such, okay, all you have to do is to calculate the molar heat of neutralization of these acids. Now, when you measure, okay, now that you have the value of this and this, okay, please remember that the first value that you get is not the molar heat of neutralization, it's just the heat of neutralization. So you have to make sure that you convert that to molar heat of neutralization. So the values are given in terms of the volume and the concentration of the acids are given. So use that to actually find the molar heat of neutralization. I think that's very straightforward. Okay, now once you have done that, okay, discuss on your results. Now do the values tally with literature. Now one thing that I want you to think about is the fact that, okay, clearly HCl and this nitric acid are strong acid, and these two are weak acid. So what is the trend, okay, in terms of this neutralization? Okay, so you need to actually do some research as well from the web I guess from the web, if you don't have a textbook, some resources to actually discuss on the delta H of this of each of the heat of neutralization of each of the acid. So that's something that I want you to discuss on, the trends and what is to be expected. Okay, so that's all for today's experiment. As usual, report contents, cover with title, name, new matrix number, objective, completed calculations, brief discussion, references, due by this, and submit to this email address. And remember to actually put your email subject as this so that I don't miss your email. Alright, so I'll see you next week for the next experiment. So thank you, and Assalamualaikum.